Okay, our first task, our first problem that we encounter is to define motion. We want to define motion. We want to make sure that we know how to represent motion. So our fundamental goal is to basically understand what we mean by motion and how to describe it mathematically. We want to put numbers on motion. So for instance, here we have this bear moving, and we would like to be able to describe this motion mathematically, meaning we want to attach numbers to the concept of motion. So motion we are going to define as the change in the object's position. So if you have an object that is moving, initially is here, then it is here, then it is here, then we see that the position is changing. Changes from this point to this point to this point. So we are going to say that there's motion there. Motion is that change in position. Also, motion would be the change in orientation, and we are going to study that later when we study rotational motion. So typically, when the object moves as a whole, we are going to talk about the trajectory of the object. For instance, here we have this basketball, and that is the trajectory, or the trajectory for this truck would be the road that is coming here. In here, we have a rotational motion, and there's not a trajectory as a whole, but there is each particle within the object has a trajectory. A useful tool that we are going to use to describe motion, to study motion, is that of a motion diagram. A motion diagram is basically a set of pictures where you have the object at different positions in time. For instance, here we have this guy, he's moving at a constant speed, right? And we don't know, I haven't defined speed or constant yet, but we'll define that. But now intuitively, we know what I mean by constant speed, right? So this guy is moving, so here we have a picture, we have another one, we have another one, we have another one. And this makes up what we call the motion diagram, and it's a tool that we can use to describe motion. Here we have a runner, and that runner is speeding up. There is an acceleration, she's increasing the speed, so we have a picture, we have another one, we have another one here, we have another one. And same for a car, for this car here, this car is slowing down, so we have these pictures here. And the key feature is that the time between pictures, this time here, this time here, and this time between these two pictures is the same. And the same can be said here. The time between this picture and this picture is the time between this and this, and it's the time between this and this. If you're taking the pictures 1 second apart, then the time between this picture and this picture is 1 second, between this and this is another second, and so on. So that is an important feature of these motion diagrams. That's what makes them really useful. Here we have a motion diagram of a basketball, and this is a 2D motion diagram in that we have 2 dimensions. We have height and we have the length here. So, and then the basketball is at these points, and let's say this delta t, the time from here to here is 1 second. So this describes the motion of the object in 2 dimensions. We have a quick question here. You can stop the video and try to answer the question, and this is what we'll do in most of these videos. I'll throw a question to you, try to stop the video, try to answer the question, and then continue. So we have 2 motion diagrams. We have car A and car B, and so both have the same interval. So if this is 1 second between pictures for the red car, is also 1 second between pictures for the yellow car. And the question is, which car, A or B, is going slower? So now take a minute, pause the video, take a minute to answer this question, and then come back. If you have done that, if you have paused the video and you have tried to answer the question, you should have probably come to the answer that this is the right answer, that this car is moving slower. And the way to see that is that it is 1 second between pictures. So let's say this was second, time equals 0, time equals 1, time equals 2, time equals 3. So this car covers this much distance per second, right? Well, here we have 0, 1, 2, and this car covers this much distance per second, and you can see that this distance here is much greater than this, so therefore this car is going slower. An important thing that we do in physics is that we create models. Models are very important, right? So we create modeling is a very important feature of us thinking physically. And by that what we mean is that when we create a model, we just try to keep the features that are important to us during our analysis. For instance, imagine that we want to study the motion of this car here. We want to study the motion of the car as a whole, right? We don't care if the car has wheels, or if it has windows, or if it has a door. We don't care about any of those details. We just care about the car as a whole and where it is located as a whole. So what we are going to do is we are going to reduce this car to a dot. So we have dots. And so that is what we call the point particle model. So a particle model is a simplification, and so when we are going, what we do is basically we get rid of everything that is not important for the particular problem that we are studying. Here we only care about the position of the whole car, so therefore thinking of the car as one dot, as a one point, is a pretty good approximation. So we have a question here. So we have two runners and they are both jogging, and then you have motion diagrams for the two runners, and then here you have the position of those dots. So these are motion diagrams, and the question is which runner is moving faster, A or B? Again, take a minute to answer this question. Just pause the video, take a minute, and then come back. Okay, we can see that A is the runner that is moving faster, and the way we see that is that this guy was here at time 0, times 1, 2, 3, 4, and so on, and this guy was here at 0, 1, 2, 3. So the time steps are the same, but then the distance here, the distance for A is greater than B, so this guy is covering more distance per unit of time, so therefore it's moving faster. One more question, so take a minute to answer this question and then come back to the video. So if you have look at this question, then here is a tricky one because we are actually having two different motion diagrams. This has a time step of say 1 second, and this has a time step of 2 seconds. So, but the distance per unit of time is this, the distance covered here. This guy covers this much distance in 2 seconds, and this guy covers this much in 1 second, right? So therefore, but the speed is the same, which is distance divided by time, and we're going to study that in more detail. So both runners are moving at the same speed.